Hi, third graders. This week we're going to talk about equivalent fractions. You need a pencil paper in two colors. I don't know if you're actually going to need the two colors, but I don't want you to have to go find them in the middle of the video. So grab them just in case for right now. Pencil, paper, two colors, and come back ready for notes. So pause the video and go get that. Okay, welcome back. So we're talking about equivalent fractions. Go ahead and write that title down so that you have it. It's right here, equivalent fractions. Now that word equivalent starts with equiv, and that kind of makes me think of the word equal. They are similar words, and that's because they have similar meanings. Equivalent fractions are definitely different fractions, but they represent the same amount. So what I want to tell you is that 1/2 and 1/2 are not equivalent fractions. They're actually just the same thing. Equivalent fractions are fractions that look different but mean the same thing. Let me give you some examples that aren't fractions to make it more less kind of weird sounding. You've been dealing with equivalence for forever. Here are some other examples of equivalence that you know. You know that 12 is equivalent to 7 plus 5. 12 and 7 plus 5 have the same value. If I actually do this math, it equals 12, right? So these mean the exact same thing, but they look different. 2 plus 3, you know what that equals. It equals 5. However, you also know that 1 plus 1 plus 1 plus 1 plus 1 also equals 5. So both sides of this equation, the side that has the expression 2 plus 3 and the side that has the expression 1 plus 1 plus 1 plus 1 plus 1, they're equivalent. They mean the exact same thing. They are worth the exact same value. They just look different. I want to give you another example. And this one's not a math example. Superheroes. You know, like Superman and Captain America and Batman. They're a great example of equivalence. Now hear me out. Sounds weird. You're like, that's not math, Mrs. Shock. Hear me out. Batman is a normal guy. And right now, off the top of my head, I can't think of his name. Bruce Wayne. He's a real guy. Well, a fictional real guy. He's Bruce Wayne. But he dresses up in a costume. He's still Bruce Wayne, but now he looks like Batman. Same person. Same thing. Looks different. The same thing's true with Superman, right? He's Clark Kent. He puts on his costume. He's still Clark Kent. But he looks like Batman now. Equivalent fractions are basically superheroes. They just put on different costumes so they look different, but they're actually worth the same amount. Now, Mrs. Waters and Mrs. Zimmerman should be very, very proud of the analogy that I just made, because superheroes are not my thing. Okay, moving back to fractions. Two fractions are worth the same if they are from the same whole and have the same amount shaded. Okay, so they're from the same whole, same amount shaded. What I mean by they're from the same whole is I can't find an equivalent fraction of this square and this square because they're not the same to begin with. Okay, won't be able to find equivalence there. Let's get rid of those two inequivalent squares. Now my two rectangles, or my two fraction strips that I have right here, I can find equivalent fractions within them because they're the same rectangle, and I know they are because I copied and pasted them. So if I look at my top one, If I shade in 1/2, that represents 1/2. Okay? If I shade in 1/4, they're not equivalent because my 1/4 piece is smaller. It takes up less space than my 1/2 piece. However, if I keep shading, now I have shaded the same amount in both of my fractions. So I can say that 1/2, this one piece right here, is the same thing as these two pieces right here. So 1/2 is the same thing as 2/4 because I've got 1/4 plus another 1/4 is 2/4. Do you see how it's the same rectangle to begin with, just cut up differently, but the same amount is shaded in both of them? Let's look at another one like that. Let's see, I'm going to do this. I'm going to give us a new rectangle. Watch how cool this is. That's a bad one. I don't want it to be that color. Okay. Okay, so I've got my rectangle. I'm going to duplicate it so it's exactly the same. I know it's exactly the same. Okay, 2 identical rectangles. I'm going to partition this one, the top one, into thirds. The best I can. Pretty close. So this is 1/3, and this is 1/3, and this is 1/3. Now I'm going to partition the bottom a different way. Let's do it this way. I'm going to start with thirds. I'm going to make it into thirds of thirds. So we'll see how many pieces I end up with. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a 1/9, this is a 1/9, this is a 1/9, 1/9, 1/9, 1/9, 1/9, 1/9, 1/9. Okay, so I can find some equivalent fractions here. I'm going to do some shading. How about I shade in, let's see, 2/3. So I have the fraction 2/3 on the top, okay? Now on the bottom, I've got to shade up to that same point. So to there. Because remember, they've got to have the same amount shaded. Well, how many 9ths was it that made my equivalent amount or same amount shaded? Well, this is 1, 2, 3, 4, 5, 6. So 6/9 and 2/3 are equivalent. They're worth the same amount, they just look different. This one is dressed up as thirds, and this one is dressed up as 9ths. It's just wearing a different costume. Interesting. Let's keep going. Okay, now I could do the same thing with circles too, right? It doesn't have to be strips, as long as my circles are the exact same size. So let's say we're talking about 3/4. So I'm going to shade in 1, 2, 3/4. Okay, 3/4. And over here, I've got to shade in the exact same amount. You know what I'm going to do? I'm going to make it the same shape. That'll help me. So I got to shade in all that. Shade it in the best I can. It's kind of sloppy, but that's okay. All right. So now I've got to count up how many 1/8 did it take to shade the same amount. 1, 2, 3, 4, 5, 6/8 is equivalent to 3/4. They look the same visually. They just have different numbers that mean the same thing. So what this is saying is that a circle broken into 4 parts with 3 parts shaded is the exact same amount shaded if I break that same circle into 8 parts and shade 6 of them. And let me show you something. It doesn't matter. Let me do this. I'm gonna do a circle. Whoop. And I'm gonna duplicate my circle. Whoopsie. Undo. Watch this. If I partition this circle like so, and I shade in, let's do 2/4, 1/4, 2/4. Let's make it 3/4 just so it's like the last one. Just the same, right? Okay. If I duplicate that, it's exactly the same. I just recreated it, didn't I? Let me see if I can show you something. I want to, I don't think it's going to let me. It's not going to do what I wanted to do. Oh, yes. It doesn't matter if it's this way. It doesn't matter if it's this way. It doesn't matter if it's this way, or this way, or this way. It's the same circle. I just recreated it, and I spun it around, right? So right now, these are still both 3/4. You're going to come into some work this week in your assignments where you're going to have to find equivalent fractions, and you're going to see it look like this. And maybe it's like this. And it's going to say to you, is 3/4 really equivalent to 1, 2, 3, 4, 5, 6/8? And it's trying to trick you, right? Because the unshaded part is here on this one, and it's here on this one. So the first time you look at it, you're going to go, no, those are definitely not the same thing. But they are. All I did was spin it around. So you're looking at as the same amount shaded, not as the exact same parts shaded. These are equivalent. Doesn't matter that this one is spun around and upside down. Woo. Okay. We can also find equivalent fractions on a number line. For example, if I have two number lines, and one's broken into fifths, as this top one is, and the one is broken into tenths, like this bottom one is, I can see a lot of equivalent fractions. 1/5 and 2/10, they're equivalent. I know they're equivalent because they line up perfectly. I also see these ones are equivalent. 2/5 is equivalent to 4/10 because they line up on the number line. 3/5 and 6/10 are equivalent. You might be seeing a pattern. 4/5 and 8/10 are equivalent because they line up. Do you see how they're stacked right on top of each other? This is also true. 5/5 is equivalent to 10/10 because we learned that 5/5 is equal to 1. And we learned that 10/10 is equal to 1. So obviously they're equivalent. It's also true that 0/5 and 0/10 are equivalent because they're both 0. So those are just 0 dressed up in two different costumes. So if we look at number lines, we can see equivalence when the number lines and the tick marks, these kind of like tallies that go across the number line, when they line up with one another like these two do, they're equivalent. Let's look at these and decide if they're equivalent. Over here, I see the fraction 1/6, 1/6, 1/6, 1/6, 1/6, 1/6, right? There's 6 equal parts. 4 of them are shaded, so this is 4/6. Okay, let's look at this guy over here. These are thirds. Are they equivalent? Is 2/3 and 4/6 equivalent? Well, I could test it. I could do that thing that I did with that last one. Let's see if it lets me. I don't know if it will. Just testing it out here with you. No, I don't think it will. Okay, we could twist it around. Another way we could look at it is if I broke this into 6ths, would then it look the same? Does it look the same now? I think it does. If I took this one and kind of just made it clearer that it was thirds, like if I did this, this is a third, this is a third, and this is a third, does it look the same now? I think it does. 4/6 and 2/4 are equivalent. It's the same fraction, just dressed up differently. Because all thirds are, all sixths are, or thirds kind of cut in half. Let's look at another one. This is one of my favorite tools, and I want to show you why. These are called fraction strips. And if we were at school, we would all have a copy of this. And I'm going to put this in one of the lessons that you can print and use as a tool as much as you want. But it's really helpful for us to find equivalent fractions. Let me show you why. Just like on the number line, anytime two fractions line up, they're equivalent. Same thing's true here. So if I have, let's say, 1/2, I can see clearly it's equivalent to 2/4. And I know it is because these two lines line up. 1/2 is equivalent to 2/4. Let's see, what other fractions can I find? How about 1/3? What's 1/3 lined up with? I'm going to just draw a straight line down. Well, it looks like it's equivalent to 2/6. See what else? Oop, looks like 3/9. They're all the same. What else? Bet there's another one. How about 4/12? They're the same. All of those fractions are equivalent. Let's look at some more. If I want to use this tool, I can use it to help me find equivalent fractions. For example, if my teacher, cough, cough, me, said, hey, what's equivalent to 3/5? That's how many tenths, for example? Well, I could use this to help me. I could color in 3/5. And I could just draw a straight line down to tenths. How many tenths is that? Looks like 1, 2, 3, 4, oopsie, 1, 2, 3, 4, 5, 6. 3/5 and 6/10 are equivalent because they line up on my fraction strips. That's really cool. What if my teacher said, and she's going to, just so you know. What if my teacher said, is it true that 4/6 is equivalent to, I don't know, 5/8? Is that true? Well, let's test it. Here's 4/6. And 1, 2, 3, 4, 5. Here's 5/8. Are they equivalent? Do they line up? If I cut this rectangle out and cut this rectangle out and lay them on top of each other, would they all match up? Would they be the exact same size? No. So then that's not true. Okay, so this tool feels like it could be really helpful for me. So there's going to be one on the Google Classroom that I could use. I could have it on my computer and look at it, but I could also print it and look at it. I might just do that. Cough, cough, cough. Hint, hint, hint. I think you should do that. Now moving on. Okay. Here's a fraction. And it is 4/8, it looks like. What if I broke each of those eighths in half? Now, I know because I'm talking about fractions, they all have to be equal parts. Ooh, bad example, Mrs. Shock. There we go. So if I break some of them, I got to break all of them, right? Now, I've broken it into 16ths. So how many 16ths are the same? Count how many pieces are orange. What did you come up with? came up with 16. Oh, nope, not 16. Crazy. I came up with 8. 8 pieces are orange. 1, 2, 3, 4, 5, 6, 7, 8. I could do that same problem, though. I'm going to make this bigger. What if I wasn't looking at 16ths anymore? What if I switched it and I was just looking at fourths? So 4/8 is the same as how many fourths? Now each one of these is a fourth. That looks like 2/4 to me. 1, 2. Interesting. Okay. What if I did it another way? What if I just took that same circle and I cut it in half? So here's half, and here's half. 4/8 is equivalent to 1/2. That's a lot of equivalent fractions right there. All I did was take the same shape, partition it a different way, and shade the same amount, and I could see what was equivalent. This looks like 3/6 to me. 1, 2, 3 are shaded out of 1, 2, 3, 4, 5, 6. Okay, what if I do this? My denominator's not 6 anymore because I cut it. I dressed it up in a costume. It's not 6 anymore. Now it looks like it's 18. Did I shade any more? No, the same amount's shaded. But now I just cut it up into different pieces. How many pieces are shaded now? Count them. How many are there? You're right, 9. 3/6 and 9/18 are the same thing. I could shade it, or cut it, a different way. What if I just cut it like this? That was a bad cut, but let's pretend it's not, just for sake of time. It was 3/6. Didn't change the shape, didn't change the amount that's shaded, but now I've got 12 pieces. And 6 of them are shaded. Those are equivalent. It's the same amount, it just looks different now. Okay, so let's look. If I had some practice problems, you will. If I had some practice problems and it said to me, 1/2 is the same as how many fourths, that means I've got to cut this into fourths. How many pieces are shaded now? 2. Okay. 2/3, 1, 2, is how many sixths? I've got to turn it into sixths. It's 6 pieces now. How many are shaded? 4 of them are. 3/4 is the same as how many eighths? Now it's eighths. 6 of them are shaded. 1/2 is the same as how many sixths? Instead of cutting this one, how about I go back to here? Okay. 1/2 is the same as how many sixths? 1, 2, 3. 1/3 is the same as how many sixths? That's a third. How many sixths is that? 1, 2. 1/4 is the same as how many eighths? So what I'm doing is I'm finding 1/4, going down to the eighths line and looking what lines up with it. 1, 2/8 is the same as 1/4. Okay, so you've learned a lot. You know what equivalent means now. It means the same thing, just dressed up in a different costume. You know that we can find equivalent fractions by manipulating the models that we have, just making sure that it's the same size and the same amount shaded. You know how to use a number line. You know how to use those fraction strips that I think you should make sure you have a copy of. And you can find equivalent fractions. So now you're ready to do some practicing on this. What you have to remember is equivalent fractions are the same amount, just looks a different way. Okay? Just like Clark Kent and Superman. It's the same human, it's just a matter of what kind of clothes he's wearing. 1/2 is the exact same thing as 2/4. It's just dressed up in a different outfit. Okay, if you need help with your work this week, you make sure that you reach out and ask for it. I am going to be available for open help on Friday afternoon, but you can email me and we can figure out a time that I can help you if you need help before then. Have a great rest of your week, 3rd graders. I miss seeing your faces, so if you got an invite to a small group math lesson this week for some extra help, make sure you show up so that I can give you that help and so I can see your smiling face. See you soon.